Hello everyone and welcome back to Java. This is the Best Mac Tutorials, and today we're going to be talking about threads and one kind of case study on how threads will be used a lot. In case I didn't mention, this is tutorial number 10 and I'm the Best Mac Tutorials, even though I'm on a PC. Because PCs actually are better, they're cheaper, they're more capable. Macs are still, let me close this, Macs are still perfectly usable, but I don't know. You can build your own PC, cheaper, faster, way better for gaming. Anyway, and programming. So, today we're going to be talking about threads, and threads was an idea mentioned in the last video's comment section by FigF-teen, thank you. I completely forgot about threads. Well, I didn't forget about them, but I forgot to talk about them, because I don't know why I forgot to talk about threads. That's actually a very important part of Java. And today, well, almost any language currently, most programming involves threads to some extent, even if you're not managing them yourself. Today we're going to be going over just the real basics of threads, the bare minimum you need to know to get going with them, and then at some later point in time, 11 through 15 tutorials, tutorials 11, 12, 13, 14, tutorial 15 are probably all going to be GUI elements. That's things like buttons, lists, images, windows, and how to make it so when one closes the whole program doesn't close. Stuff like that. So we'll be talking about that and a lot of other cool things with GUI elements. We won't be getting really advanced into GUIs, but we'll be getting far enough to make applications with multiple buttons, that each button will pop up a list of stuff. Users can add to it. It'll save data. We'll be through the tutorials building probably one or two big programs in multiple stages. But anyway, this is threads, not GUI, so I'll stop talking about GUIs. GUI is graphical user interface, by the way. Threads are basically instances of a program that are running. Now, threads weren't as big of a thing back when we had single-core processors, but nowadays with dual-core, quad-core, hexa-core, and even servers with 8 or 16 total cores, i7s with 8 logical cores once you throw in your hyper-threading, things like that really demand that you write any kind of intensive application to use threads. And so today we're not going to be going into real advanced things about threads, of how to create them and then join them all together at a certain point and then call them out with different information, all that kind of stuff. We're just going to be focusing on their use in something like a port scanner for network diagnostics. So one thing to mention with port scanning, it is basically, you can imagine a port on a network as like a road. A port is a road or an entryway that stuff can go in and out. You can almost imagine it like a giant building with about 65,000 or so doors all the way around. Some of them are locked, some of them are open, and the ones that are open have someone there waiting to use there generally. So obviously, with that whole kind of analogy there comes the part of it would be generally not allowed for you to just go to random houses and jiggle the doors to see if they're open, or if they're open, just walk in, obviously. So same applies to port scanning. You're not allowed to really scan things that don't belong to you, things you aren't authorized to. So don't go around scanning Yahoo and Google and stuff like that. That's just not a good idea. So, but it's useful for internal network testing. It's useful for testing what's open on your own network, testing your own network from an outside source, things like that. And so this one's going to be sending basically send flood packets, which try to establish a connection to a port. And if they time out, then the port's closed, we presume. And if it makes a connection, then the port must be open. And sometimes a port will be open, but it won't work for a service because it's a different service running on that port than you think, but it's still open. So all it's going to tell us is that the port is open. So it's actually pretty simple to write a port scanner in Java. Even make it multi-threaded is quite an easy task. So let's just do it non-multi-threaded to start with so we can see the huge performance difference between multi-threaded and non-multi-threaded. So let's create a couple of class variables here. Private string host and private int port. Actually, no. Create that later. But in here we're going to do host equals localhost. And we're going to do a for loop for int I equals 1, not 0, 1, because I want to start on port number 1, not 0. I is less than, let's scan the first 10,000, so 10,001. I increment, the reason I did 10,001 is because I did less than. I could also do less than or equal to, and then 10,000 instead. So, the way we private static string. Sorry about that. The way we scan, the way we test to see what port's open is we try to make a socket connection to it. So we do something like this. Socket equals new socket, host, and I. Not a very exact, or not a very, it's a very redundant statement. Socket equals new socket, but that's what you do. We're going to have to throw a try-catch block around it, and these are the two exceptions that it's likely to throw. Now, I only care about unknown host exceptions, so I'm just going to turn this to a generic exception. Here I'm going to delete IO, and this will be E2. But, however, our catches, I like all the braces lined up. E2.printStackTrace with just a regular exception, whereas with an unknown host exception, that's what we'd probably be throwing. However, I'm just going to delete this, and I'm just going to catch an exception and print out that the port wasn't open. So system.out.println, the port, oops, actually let's just do port plus I plus is not open. And the 3 dots, 3 ellipses, and the exclamation mark, just because we can. And so this is called whenever this socket fails, whenever it times out, whenever it gets rejected or the connection gets dropped. This exception here in this catch block is called. So if this gets called, the port scanning didn't go as intended, aka the port connection wasn't able to be established, the send flood packet was rejected, whatever. And so if this succeeds, though, it'll go on to the next line instead of jumping to the catch block. And we'll do system.out.println port plus I plus is open. And put a space here, and let's do 4 ellipses, just because we can. Because why not, right? And so if we run this is a pretty basic program. You'll see how slow it is. Port 1 is not open, port 2 is not open, port 3 is not open, port 4 is not open. And as you can see, it's just kind of dragging on with that. Takes about a second between each one, as you can see. That's about the timeout time. The overhead is very minimal, as you can see. Well, you can't see it right now, but if I brought up my any kind of system monitor or something, you'd see CPU usage, at least from this, is very, very low. So it's not a very CPU intensive program, and so even if I was on a single core processor, multi-threading this would still give me a huge advantage, because most of the time here is spent not processing but just waiting, and then once it waits, then it makes a new one. What if you could start them all at the same time, relatively speaking, close to the same time, and then all the ones that don't time out, you print out that they're open. So if we keep waiting, we'll eventually find an open port. And I think port 80 on this computer is open right now. I think HTTP client is bound to it. So let's wait till 80. Actually, I'm bored. Let's change this to 78.